Welcome back to ArmanisMath. Today we're going to focus on subtracting rational expressions. Subtracting rational expressions. I have this example here, x plus 1 divided by x squared minus 6x minus 16 minus x plus 1 again, x squared divided by x squared plus 6x plus 8. And we said that you can't subtract or add unless if you have basically a common denominator, least common denominator. So we're going to have to look for this least common denominator. There's no way for me to know what's inside these two denominators unless I factor them out. So I'm going to take the side here of the board and actually factor them out. See what's inside of them so I don't have to repeat myself. So I'm going to factor x squared minus 6x minus 16. And we're using the diamond method to factor. It's one of the methods to factor quadratics, which I have to have a knowledge of ABC, and ABC are the coefficients. A is 1, B is the one next to the x, which is -6, and lastly C is the constant by itself, which is -16. At the top of the diamond goes A times C, like the air conditioning AC at the top, and B basement bottom at the bottom. So I'm just trying to put the numbers here. 1 times -16 is going to be -16 at the top. And at the bottom, the B, which is 6, or I should say -6. Two numbers I'm thinking of to multiply give me -16. Same numbers, if I add them up, I'm going to end up with -8. Go ahead and suggest the two numbers in the chat or in the live stream comment or in on your whiteboard. There is a lot of us here. I need all of us to participate, not just one or two. Okay, so make sure that you participate. Make sure this class, again, you share your thoughts. Not, I like that, Ryan, thank you for the whiteboard. The suggestion was -2 and 8, -8 and 2. Let's try that. -8 times 2, that's a -16. That works at the top. Okay, that's good. Happy face for that. -8 plus 2, that's the -6. That also works at the bottom. Good. The second question is does A equal 1? If A equals 1, that means I'm ready to put these into a factored form. Basically, you're going to put these into parentheses. So I have x minus 8, and I have x plus 2. That was for this type. So I'm going to replace these two factors with this dude here. Again, what we're trying to do is not duplicating the denominator. So I need to be able to find out what's inside the quadratic. So I would kind of lessen the work in terms of coming up with a common denominator, least common denominator. So that was what's hidden inside of x squared minus 6x minus 16. Now I have to find out what's hidden again behind x squared plus 6x plus 8. And for that, I also have to factor. One of the ways we used to factor, as I said, is the diamond or the big X. And in this case, what do you guys think? I have x squared plus 6x plus 8. Can somebody tell me in the live stream or chat or on your board, what is the ABC for this here? What's ABC? A1, B is 6, and C is 8. That is very true. And at the top of the diamond again goes AC. So 1 times 8 is 8. At the bottom is going to go 6. And two numbers multiply give you 8. Same numbers add give you 6. What do you think these two numbers are? I need all of us to participate again. Remember, in this class, you share your thoughts. Doesn't have to be your correct answer. Doesn't have to be. So I'm going to wait for a couple more to share. Okay, got that, Ryan. Kiera, I see that. Kathleen, I see that. Yoshi, I see that as well. So you're suggesting 2 and 4. 2 times 4 is 8. Yep, that works at the top. And 2 plus 4 is 6. That also works at the bottom. So I'm going to go down here and basically have them as my factors. X. Let me be consistent with colors here. So I'm going to choose the blue. X plus 4 and X plus 2. Okay. Well, I'm going to go and replace these two with my quadratic that showed up here. So this is what we mean by that. And now we have another set of factors. And X plus 2. Now, the question is, I said this is going to be a little bit lengthy problem, so just pay attention as we go through. The question now becomes, this is a denominator here, and this is another denominator. Is there anything that in common between these two guys? Because remember, you have to look for the least common denominator. Multiplies of, yep, there's multiple of X plus 2's, which is a blessing, by the way. The reason we unfolded these two quadratics is to find out their factors and find out if we don't have to repeat a factor again. So in this case here, looks like I'm missing. What am I missing here, do you think? That I have to match this side. This side has to match this side. What do you think I'm missing here and this side that is found here? The whole thing, right? I'm missing the entire thing, which is the whole this entire factor, X plus 4. So I have to come here and put X plus 4. That's what's missing from this side here. So I'm going to put that top and bottom. Why top and bottom, by the way? Well, because again, top and bottom, if you multiply anything by a fraction like this, you're basically saying you're multiplying it by 1. So you're not actually affecting the value of the function, or the expression in this case. So that's why you multiply top and bottom. So I'm going to go here and multiply. I actually need to give myself more room. So I'm going to go down here. I'll go down here and put this factor again. X minus 8. X plus 2. Minus, I'm going to put this factor here. Give myself more room. X plus 4. X plus 2. Okay, and this is X plus 1. X plus 1. All right, we said that what we're missing here. So let me also show this in a different way. How many factors do we have here? How many factors are these here? Can somebody tell me? How many of these do we have? How many of these do I have here? I just circled them. Got 2 here. And how many down here? I also got 2 down here. So basically my eyes are looking at 4 factors, and in the hope that I have one of them that is repeated, so I don't have to repeat myself. And in this case, X plus 2 was repeated. So basically every I'm going to put the least common denominator. Every denominator that I'm going to use will have to have 3 items. X plus 2. Remember, that one was repeated, so I'm not gonna list it again. And then I have X plus 4, and then X minus 8. So every denominator has to have these. And that's why when you look here, the only thing that is missing here is X plus 4. So you have to compensate for that. So that's why I'm gonna have to multiply top and bottom by that, whatever I'm missing. X plus 4, and then again in parentheses is a factor. More room. X plus 4 and X plus 4. What's missing on this side, you think, to get this entire LCD. What's missing on this side? What's missing on this other side of the fraction here, of this fraction? What's missing in the denominator? If I have to end up with these three. Here we go. X minus 8. X minus 8. And then obviously going to do this up, top, and bottom. Numerator and denominator. X minus 8. Okay. So now these two could start to talk because now I have a big, good old, I really have a big, long fraction like this. Woo! I do. Which has x plus 4, x minus 8, doesn't matter how you arrange them, as long as you capture all of them, you should be fine. X plus 2. This is my entire new LCD, least common denominator. And then I have this one at the top. I've got x plus 4 times x plus 1. Now you really have to be very careful here because there's a negative. So I'm going to use a different color for negative. Let's say negative, whatever is going to come after that. Okay, guys, are you with me? Give me a thumbs up if you're doing good here. Thumbs up if you're doing good. Okay. Yes, Ryan, I see that. I see that. Minus what's gonna come after, which in this case, and I really am a big fan of making this clear. So I'm gonna have to use a bracket in this case because I'm afraid that you're gonna miss. It's minus the entire thing, not just one. So I'm gonna say minus this, and then I'm gonna put my two parentheses. X plus 1 times x minus 8. And then I'm going to close this bracket here and extend my fraction. Okay, so one thing at a time. I want to go again and try to see this dude here. X plus 4 times x plus 1. Well, we talked about at least 4 different ways you could do that at the beginning of the semester. How you multiply binomials, like 2 items times 2 items. So we are gonna, I'm gonna use the box. I'm not sure about you, but that's my favorite because I could see, unless if there's a shortcut. So I'm gonna use the box for my case. So I'm gonna go here, and then again, this is my work area. My work area seems to be getting bigger and bigger. Okay, so I have x plus 4. I'm gonna use the box again. And at the top, I'm going to x plus 4. And at the side, I'm going to x plus 1. Put x plus 1. X times x. Here's a question here. Why can't you cross cancel? Oh, that's a good question. I cannot cross cancel because there's a negative sign here. I'm subtracting. I only could do that if I'm multiplying. Very good question. I can't say this and that are going to go away. I cannot say that. I have to have them multiplied, not added or subtracted. Very good question. Very common mistake. X times x is x squared. X times 4 is 4x. Somebody help me out, please. X times 1. What is x times 1? Is x. Good job there. And then I have 4 times 1 is 4. Now, because I've done a lot of these boxes, so I'm going to simplify within the box. I got x squared. I got 4x's here. And I've got 1x here, so I'm going to collect them together. As I said, you only do this once you do a lot of boxes and you know what you're doing. Otherwise, you have to list them down here and then just add them up. But for my case here, I'm going to have x squared plus 5x's plus 4. And that's exactly what I'm going to replace at the top here. So this dude, I'm going to replace with this amount. So I'll go here again and with this pretty long fraction. So I've got x squared plus 5x plus 4. Okay, that's for the first one. And then I'm going to change the sign and put my bracket back again after I found out what's here. So in this one and in this one at the top, I still have to multiply x plus 1 times x minus 8. So back again to the back again to my work area here on the side. I'm gonna also use the box. I'm not sure what you guys want to use, but that's my favorite, so I'm gonna use the box. I'm gonna say x plus 1 x plus 1. Then I've got x minus 8 minus 8. Somebody help me out here. X times x is how much? X squared, thank you. Let me scoot back just a little bit. And 1 times x is x. How about x times negative 8? Kiera's, I need to see you guys. Maddie and Nicholas and come on. Yep, I see that, right? Negative 8x. And then 1 times negative, that's a negative 8. As I said, if you do more of these boxes, you know, you could simplify with inside the box. So I've got x and negative 8x's. So basically, I am looking at x squared minus 7x's minus 8. Okay, that's what I'm going to replace at the top here. So it's going to be x squared minus 7x's minus 8. And I'm very careful with this negative sign, otherwise I'm gonna make a mistake. So I'm gonna be very careful with this negative sign. Okay, so in here I'm actually gonna distribute this negative sign at the moment. So I'll go like this. And that's why we said you gotta protect it with brackets and parentheses. Okay, at the bottom, if you guys remember, what did we have at the bottom? Does anybody remember? What was the bottom looking like? Does anybody remember the bottom? What did we have at the bottom? Hello? Maddie, are you here? Kieras, Tatiana, Alexia, Andrea, Juliana. So at the bottom I have the denominator, which is x plus 2. And then I have x plus 4. I have x minus 8. I know it's too long, but we didn't really have to multiply by 2 things. All this just multiplied by 1 item. Anyways, so let's be patient here. X squared plus 5x plus 4. Now minus x squared. Minus 7x. Is it minus or is it positive? So somebody tell me, is it positive or is it minus? Hello? It's positive. That's why we have to be very careful. Positive. And then positive 8. Yep. I would highly recommend using different color pencil as well when you do problems like that. So make sure that the signs stand out. You do not miss it. Okay, so x and x squared, well, guess what? These two guys are going to go bye-bye. This dude and this dude are going to go bye-bye. And then I've got 5x and 7x's, that's 12x's. And the 4 and the 8 is how much? 12x's. How much is 4? How much is 4 and 8? Not 5 and 7, that's 12x's plus 12 divided by this humongous x plus 2, x plus 4, x minus 8 Okay, good. And I mean, it's good, but at the same time, maybe I could simplify this a bit further. Perhaps I could simplify this further. And yeah, I could. I'm looking at two things that look alike here. So I'm looking at the 12 and this 12 here. I could factor that out. So let me factor this out. So I'm going to factor out the 12, open parentheses. So basically you're saying 12x divided by 12. Again, the work area is actually very big in this problem. It's very big. So 12x divided by 12 is what we're trying to do here. How much is 12x divided by 12? 12x divided by 12 is how much? Be careful. Here, yes. Now we got it. Lindsay. Yep, that's correct. Yeah. Lindsay and Yoshi and Kennedy, Kathleen. Yep. It's gonna actually be x. So I have x. How about 12 times 12? Now now you guys are. Now you are correct. 12 over 12 is 1. So plus 1. At the top. And back to down here. X plus 2. Does this even help? Does this even help? Did not really help. I mean, I thought that I'm going to end up with something close to the x plus 2, for example, something so I could cancel stuff out, but I didn't. So that's okay. I factored it out anyway. Okay. So that should be the result of this problem. I want to point out one important thing. When we did the least common denominator here, you've got to be very careful that you should not include certain points, I should say certain x values, that will make the denominator 0. You're trying to avoid this. We always talked about this item. You're trying to avoid this from happening. This here. So what could make the denominator 0? Look here. What could make this 0? What kind of value of x? What kind of x value would make this denominator 0? Well, actually I have more than one in this case. Can somebody suggest? Values, if I change them, if I change the x and substitute it for a value, it's going to make me a 0. It's going to give me a 0 in the denominator. Which values are we talking about here? Nicholas, what do you think? That looks good, Ryan. The question was, I'm trying to avoid this scenario here. Having a number divided by 0, I'm trying to avoid 0 in the denominator. What does make my denominator 0? What values of x would make my denominator 0? So I have to exclude them from my x's, from my domain. What kind of x's would give me 0s here? Shalom, Tatiana, Yoshi, Giovanni, Alexia? Okay, looks like numbers are coming up now. 1 second, Ryan. Numbers are coming up now. I got -4. If I put -4 here, so let me, hold on a second. If I went here and said, I'm gonna, you know what if my x is -4? So I'm gonna put -4. Well, -4 plus 4 is gonna be 0, which is not a good thing, right? So it's gonna make the numbers. So basically you're saying you cannot have -4. You can't have that. What else? Kennedy says I can't have 8. She's right. I cannot have 8. If you put 8 here, 8 minus 8 is going to be 0. So you can't have 8 either. Can somebody tell me? Here's Ford. Kiara's saying that you should not have -2. She's right, because if you have negative 2 plus 2 is 0, you divide it by 0, that's undefined value. So basically what you have to say here, x does not equal to negative 2 or negative 4 or 8. You should avoid these for x. Otherwise you're going to get undefined value, because you're going to be dividing by 0. Okay? There's obviously something happens in these cases, if you guys remember the vertical asymptote. But to us right now, the domain should not include these 3 values of x. We should not include these values for x. There was a question on how did we do the 12x plus 12. So I noticed something in common here, Ryan. So I noticed that 12 is in common. So I pulled that out as a common factor. So and I said this is 12 as my common factor, open parentheses. And then I have to take my first term, the 12x, divide that by 12. That's give me the x. And then I got the plus 12, divide that by 12, that's going to give me the 1. Yeah? Did that help, Brian? Okay. All right, so keep in mind when you do these problems, you guys, you will have to really pay attention to the denominators and exclude any value that makes it undefined. So the domain should not have, the domain for this function should not have these values. It's 3 values here. Any x you would like is fine, except negative 2, negative 4, and or 8. You should not have these values.